Welcome. Today, we're going to talk about how we can create a continuous piecewise function. We can say that a function is continuous if the function does not have neither a hole or a gap in its graph. So let's take a look at the following piecewise functions, and let's think of ways to make sure that there is no hole or gap in its graph. Let's take a look at the first example. So here we're going to have a function whose name is f of x. And notice that this is a piecewise function. Here we have the first line in the piecewise function, and here we have the second line in the piecewise function. But notice that in the first line, we have a parameter, a letter k. And what we want to do, we want to look for some values for this letter k that will make the piecewise function of f of x a continuous function. Well, one thing to notice is that the first line in the piecewise function, it's only using values of x's that are less than 5. And the second line in our piecewise function, we are only using values of x's that are greater or equal to 5. So if we want to make sure that there's no holes or gaps in our graphs, we want to make sure that whatever the first line in our piecewise function ends, exactly at the same location, the second line of the piecewise function is going to start. So let's visualize that. But notice that the switch between the first and the second line, it's happening at the value of x equals 5. What we want to make sure is that whenever the first line ends up at the value of x equals 5, exactly at this location, the second line should continue. Because when this occurs, notice that we will not have neither holes or neither gaps in our graphs. And how can we guarantee that this occurs? We want to make sure that at the value of x equals 5, both functions have the same y value. So this is going to be our strategy. Let's go back and take a look at the piecewise function of f of x, and let's make sure that at the x value of 5, they both share the same y value. So let's clean this up, and let's do that. So first, let's make sure that they have the same y value. If you want two functions to have the same y value, let's set those two functions equal to each other. Now let's make sure that the same y value occurs at the x value of x equals 5. So let's take a look at the function that we created, and now let's substitute x being equivalent to 5. Now let's calculate 5 to the second, that's 25. Bring down the k. 2 times 5, that is 10. And now notice that we can solve for k now, because that is the only unknown that is left. So now let's solve for k. The right-hand side is 9. Now let's subtract 25 to both sides. So now we're going to get negative 16 on the right. And to solve for k, let's divide it by negative 1 to eliminate the negative. So now we have what we were looking for. If we let k be equivalent to 16, we will have a continuous piecewise function because we will guarantee that the both lines on the piecewise function, they will share the same y value at the location of x equals 5. Let's visualize this result. So now here we have both lines in the piecewise function in our first example. What we have here in red, it is the first line in our piecewise function, and what we have here in green, it is the second line in our piecewise function. And right now we're looking at the result when k is equivalent to 0. Notice that when k is equivalent to 0, we have a big gap between those two functions. So now let's increase the value of k, and let's see what does that do with both functions. And notice as k it's increasing, the gap between those two functions, it is decreasing. And notice that when k it's exactly 16, there is no more gap between both functions. And the reason why there's no gap, it's because when x is equivalent to 5, we are guaranteeing for both of them to have the same y value, which is the result that we show algebraically. Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.